Let's take a look at this image by Dr. Suresh Muthakamaraswamy of Cardiff University. On the left, we have substances that primarily influence GABA and glutamate systems, such as zolpidem, gaboxidol, tiagabine, propofol, and alcohol. These substances are known to increase brain activity, as indicated by the prominent red regions in their MEG scans. The red color here signifies increased activity across different frequency bands like delta, theta, alpha, beta, and gamma waves. Zolpidem, for example, is commonly used as a sedative to help with sleep, while propofol is widely used as an anesthetic during surgeries. These substances, by increasing brain activity in specific regions, seem to suppress the brain's capacity to enter altered states of consciousness, which are often associated with mystical or psychedelic experiences. Now, shifting our focus to the right side of the image, we see substances like ketamine, psilocybin, and LSD. These are well-known psychedelics. Notice the significant presence of dark blue across their MEG scans. The blue indicates a global reduction in brain activity. Studies have shown that this reduced activity correlates with the intensity of psychedelic and mystical experiences reported by users. This difference in brain activity helps explain why people under the influence of sedatives, anesthetics, or even in states induced by heavy alcohol consumption, often don't report mystical experiences like near-death experiences. The increased brain activity in these states seems to block or filter out the possibility of such experiences. This brings us to an interesting philosophical idea known as the filter hypothesis, proposed by Aldous Huxley and Henri Bergson. This theory suggests that the brain functions as a filter, limiting our perception of reality to what is necessary for daily survival. When brain activity is reduced, as seen with psychedelics, this filter is relaxed, allowing for a broader spectrum of consciousness and mystical experiences. In conclusion, this image provides a compelling visual representation of how different substances modulate brain activity and, in turn, our conscious experience. The contrast between the substances on the left and right highlights how increased brain activity can suppress, while decreased activity can enhance the likelihood of experiencing altered states of consciousness.